Today we will talk about transformation of energy that occurs during physical change. Change of physical state from solid to liquid, liquid to gas, and backward from gas to liquid and then to solid. To talk effectively about those terms, we need first to define what we call solid, liquid, or gas. Okay, solid is the piece of material, piece of matter that has definite shape and definite volume. The molecules are located in the rigid structure, and while they have certain amount of kinetic motion, but they have the least amount of kinetic motion out of the three physical states. When it comes to liquids, molecules are more loosely arranged next to each other. So the liquid does not have a definite shape as our solids used to have, but however, liquids still have to have a definite volume. Regarding shape, liquid just takes the shape of the container it occupies. And when it comes to gases, gases have the largest amount of space between the molecules, and there is no definite shape or volume to the gases. The volume of the gas just would occupy whatever volume is given to it. It expands to the size of the container it is given. And there can be no fixed shape for the gas. It would just occupy and fill up the entire container. Now let's look at this graph of changing temperature of a substance as we putting energy into it. You can see on the y-axis that we have a temperature of a substance in degrees Celsius, and x-axis of this graph represents amount of heat that we are transferring into it. Our initial temperature here is 40 degrees Celsius. Pretty hot to begin with, but as we continue to transfer heat into that substance, the temperature of the substance increasing until it eventually hits 60 degrees Celsius. Then look at this, we continue to provide energy, we continue to pump heat into the substance, but there is no change of temperature observed on this part of the graph. What is happening during then? Well, apparently there is no change in the amount of kinetic energy because temperature is not changing. But since we are transferring energy in, it should be going somewhere because energy cannot be created or destroyed. So what is happening here is that we are increasing, during this period of time, we're increasing the amount of potential energy of the substance. The heat that we are transferring into the substance is not lost, is not destroyed. It is converted into potential energy. And since thermometer only can inform us about changes in the amount of kinetic energy, we cannot observe any changes in the temperature during that time. Okay, so over here the increase in the amount of potential energy ends, and we again observe the increase in the temperature, meaning that during that period of the graph there is increase in the amount of kinetic energy, which very easily can be detected on the thermometer. The temperature is increasing from 60 degrees to 120 degrees Celsius. We continue to to provide substance with the heat. We continue to put heat, to transfer heat into the substance during that period of time, and we observe increase in the amount of temperature. But once again, at 120 degrees we hit that plateau, during which, while we are continue to provide heat to the substance, we do not see any increase in temperature. Once again, we found a place where we are providing the heat that is converted not into kinetic energy of the substance, but it is converted into potential energy of the substance. During that period of time, we do not see change in temperature because it's not an increase in kinetic energy that is happening here. It is increase in potential energy here, and thermometer doesn't tell us this story. Eventually, we see once again our substance starts to increase in temperature after we finished with the second plateau, and we see the increase in the amount of temperature at the end. So what was happening here and here on the graph? During those period of time, there was a change in the physical state. At 60 degrees Celsius, the substance that was solid before that started to melt. And as the substance was melting, there was an increase in the distance between the molecules. So it was the change in the position of the molecules and change in the amount of potential energy uh, that is happening over here. During this period of time, the substance exists in two states. Some of it is still solid and some of it was already liquid. As we continue to provide energy, there will be more liquid and less of a solid until eventually the very last piece of the solid is melted and our substance in all and absolutely complete liquid. Once the substance is completely melted and now in a liquid physical state, it once again will be increasing in temperature as we provide heat. As a liquid, as a liquid substance absorbs energy and its temperature is increasing. The temperature is increasing until this moment at 120 degrees. The liquid reached its boiling point. The liquid starts to boil. Once again, we are observing the physical change of a substance. From liquid, it becomes a gas. So over here, once again, there is a huge increase in the space between the molecules, so there will be increase in the potential energy of the substance, which our thermometer would not tell us about, because the thermometer only registers changes in the amount of kinetic energy. But during that period of time, our substance exists in two states. Some of it is already gas and some of it still liquid. Over here, this plateau is the place where there is a change in the amount of potential energy, increase in the amount of potential energy. That is happening until that very last piece of liquid was turned into gas. Once our substance all became gas, as a gas, that substance once again will be able to increase in the amount of kinetic energy if we provide it with amount of heat to increase its kinetic energy. Temperature 120 degrees represents boiling and condensation point. At this temperature, this particular substance will be boiling if energy is transferred into this substance, and at this temperature this particular substance will be condensing if the heat is leaving it. And 60 degrees represents a melting point or freezing point of the substance. If we putting energy into this substance, if we're transferring energy in, then this substance would be melting at 60 degrees Celsius. But if energy is leaving the substance at 60 degrees, this substance will be freezing. To recap, heating curve shows us what is happening to the amount of energy in the substance, to the temperature of the substance as we increase amount of energy in it. The red segments of the graph show us the increase in temperature of solid, liquid, and gaseous states of the substance. The purple segments of the graph show us increase in the amount of potential energy of the substance as the change of physical state occurs. Over here, that would be melting, and over here, that would be boiling. During the change in the physical state, the substance exists in two physical states at the same time. Over here it exists as a liquid and a solid, and right here it would be existing as gas and a liquid. Temperatures at which plateau appear on the graph can be identified as melting or freezing point of the substance or as boiling and condensation point of the substance. Let's have a quick review of heating curve on this heating curve of water. Here is my solid water. It's ice that is warming up, eventually reaching the freezing point, the melting point, and starts to melt, during which it exists in the state of water and ice at the same time. And when everything is melted down, my liquid water starts to gain kinetic energy and increase in temperature. Eventually it hits boiling point and starts to boil, during boiling water and gas exist at the same time. Water vapor and liquid water exist at the same time. And I don't see change in temperature because there is increase in potential energy during that time. Eventually, when everything is vapor, then the vapor can be increasing in temperature if I keep providing heat for it. Up until now, we have called this kind of graphs heating curves because we always assume that we are adding energy to the substance. But if you think about it, the heating curve is also can be considered a cooling curve if we look at it from right to left. We imagine that we are actually stealing energy. Energy is leaving the substance. Let's say our substance initially in the gaseous form. As the energy leaves, the kinetic energy of the molecules is decreasing and the temperature of the gas is coming down. Eventually, when the gas reaches the condensation point, the molecules start to stick around and they are condensing into liquid. So at this point, there would be decrease in the amount of potential energy during condensation. Water and gas exist at the same time, but as the energy coming out, there will be less and less potential energy in the substance, and eventually our substance will be all turned into liquid. As a liquid, it will, as if we continue to take energy out of the substance, the liquid will decrease in temperature because there is decrease in the amount of kinetic energy of the molecules in the liquid. Eventually, liquid will reach the freezing point at which there will be no change in temperature for a little while, even though the energy would be coming out of the substance. During that time, our substance will exist as water and ice, and then eventually it will freeze completely. And as a block of ice, when everything is already solid, if we continue to take energy away from the substance, that block of ice will become colder and colder and colder as the amount of kinetic energy is decreasing in it because the heat is leaving that substance. Take a look at this graph. Over here we have a substance that is cooling down. It is a heating curve flipped because we have initially substance at a very high temperature over 200 degrees Celsius. Then it is cooling down as a gas, then it is condenses, and then it's cooling down as a liquid. Eventually it hits the freezing point, freezes, and then cooling down as a solid. From this graph, we can identify the boiling point of the substance to be 150 degrees, and freezing point of the substance would be 90 degrees Celsius. These red segments of the graph represent the segments where we can observe the change in the amount of kinetic energy of the substance. And the blue lines over here, segments of the graphs that are in blue, they represent those segments where there is change in the amount of potential energy, but there is no change in the amount of kinetic energy during them. Also in this graph, the x-axis shows time, but we can figure out that the heat is leaving this substance because we see the decrease in the amount of temperature as the time goes by.